Fabulous. Thanks, Joel. And thank you for the intros. I'm emotionally scarred from fluffing them last time, so I asked Joel to take over this time. So basic housekeeping. If you're a previous consumer of a CTO craft release, then you'll know that you need to leave your questions in the column somewhere on your screen, and we will read those questions at some point. And if you're new, you need to do that. There you go. So let's start with the questions that we've got. So the obvious one, Guy, what is DevSecops and why should folks be incorporating this way of working into their business?
Sure. I guess first of all, thanks for having me on. Great to kind of be here with this great audience and yourself, Aubrey. So DevSecops, fundamentally, DevSecops is around security catching up to DevOps. When you think about DevOps, it really it changes the way we build software, the way we run businesses, and it predicates on independent teams. The whole idea is that you have this sort of smaller set of teams that are operating continuously, right? Sort of tightening that loop from like writing a line of code to getting it to a customer, to understanding what has happened and then adapting and tightening that, doing it as quickly as possible. And for that to be fast, and for these teams to be, the teams need to be independent. They can't have bottlenecks that are centralized that make decisions for them. And so the whole ecosystem around it, and you can argue the chicken and egg around technology and kind of practices over here, but the whole ecosystem around it has evolved to allow to turn infrastructure into APIs and software. To there's the practices and learnings that have changed DevOps teams, from being the ones kind of operating the servers to building platforms so that engineers can do it. Everything is all around allowing these teams to sort of, if you build it, you run it, to do that successfully and own it end to end. And, by and large, security hasn't come along for the ride. Like security has remained a fairly centralized entity that tends to still make decisions, doesn't empower, definitely deals with the vulnerabilities far too much as opposed to sort of, equipping developers to do it. And that just can't continue. It means that the end result in this reality of DevOps is that security is either it is being kind of worked around, so people just don't do it. Not because they don't care, but because they have a lot of things they care about, and security is just too hard. Or it's become a bottleneck, and it basically gets in the way of the business being successful. So DevSecops, I don't know if it's that simply, but fundamentally, it's around doing to security what has happened to ops. It's around changing the whole approach of the industry and the tools that are built and the methodologies around it to be such that security teams govern by building platforms, by being escalation points, by being centers of excellence that are all orient at helping developers build securely. Developers are the ones making decisions around the infrastructure they choose, the code they write, the logic they embrace, the libraries they use, everything around that. And so if they're the ones making the decisions, they're the ones who need to be equipped to make those decisions securely. And it's a fairly, just like DevOps was a fairly seismic shift to the world of ops, it's a fairly seismic shift to the world of security. So not easy.
Fabulous. And just picking up on something that you said there, this, I guess, the historic centralization of these functions. Do you think that there's a need for things like CM and SOC and that mentality of centralizing those functions to change? Do you think the software is almost like an enabler for that centralization, and something needs to happen there to decentralize and distribute that control or that responsibility towards those development folks?
It's the SOC and the CM are an interesting question. I mean, generally speaking, I think security should be done at the point of decision. And so really the question is, who is it that you expect to make the decision at a given time? And therefore, how do you equip them to make that the secure decision? And so when it comes to like building software or picking a library or defining your Docker file and which operating system you're going to use it, or base image, or definitely things inside, all of those are already in the cloud native world, at least, very much developer decisions. I think that's not very arguable. Terraform scripts, for instance, are a bit more Twilight Zone. Sometimes they're sort of more DevOps teams or sort of platforms teams that do it, sometimes developers. Incident managed, like on-call duty, is definitely developers. So like when a server goes down, the person gets paged is oftentimes a developer now. You need to know enough about your cloud infrastructure. when there's a concern about, hey, this might be a breach, do you ping a developer? I think we're not there yet. Like, I think today we're a little bit further out. But what you see in the industry is that you see the DevOps players move into the SecOps space, and you see the SecOps player move into the DevOps space. And I do think that over time, incident response and the decisions around understanding runtime and operating your systems will converge a lot. And there are, I guess the industry is kind of demonstrating that as well.
And so in a world where I guess we've been taught to be metric obsessed and to use them to examine whether we are achieving the outcomes we set out to originally achieve, is it possible to measure security? And if we can, how can we do that? And how important is it to measure it?
Yeah, very important and very hard. I actually run a podcast called The Security Developer. I guess a bit of a shameless plug here. And I get to talk to these smart security leaders and all sorts of things. And it's like the pocket question of how do you measure security is always okay, if you seem to have good answers to all these other things, can I ask you the impossible question? How do you measure security? And it's very, very hard because security is naturally invisible. Security is, you bought this amazing lock for the door and nobody broke in. Did you do the right thing? Like, should you have bought that lock, or you didn't buy that lock and nobody broke in? Are you kind of playing with fire here, or it's very, very hard. And I like to say that, it doesn't hurt until it hurts really bad. That's the sort of the reality of it. And at the same time, I think the DevOps mentality of sort of massive instrumentation, and I'm full of cliches here today, but if it moves, measure it. If it doesn't move, measure it in case it moves, right? Like all of those philosophies from DevOps are very applicable here as well. You can't fix it, you can get better if you can't measure it. And so in practice, I think it is very important, despite the fact that it is practically impossible to truly measure security, to have some leading indicators. I see companies doing three different things. One is measure the applicability of their security, the adoption of their security programs. So say you define it that every library you use should be vetted, right, with some sort of security tooling, right, or that your code should be scanned, or that you wouldn't deploy anything that is whatever, some unstable or hasn't gone through testing to production. And so when you do those tests, you now need to see, okay, are we actually adhering to those? You're sort of defining security controls. And the first level of it is, are we actually running the tests? That's already fairly hard. So that's one. That's the basics, and everybody should be doing it. The second is measuring the output of those security tools. So easiest example is vulnerabilities. You ran a scan, you've got a bunch of vulnerabilities. What are you doing about them? So you define what you think you should be doing. I should be addressing all vulnerabilities above a certain criteria within a certain time frame. I should not have a backlog of more than XYZ vulnerabilities. And so you want to address those. Similar around, we talked about the SOC. How quickly do you respond to incidents? How quickly do you resolve them? So all of those are metrics of how do you actually respond to the outputs of your security controls. And those are also reasonably popular, and you can do them. There are many depths. And then the third, that is the best but the hardest, is to measure the efficacy of your security controls. So how good are they at actually sort of reducing your risk? And there's no perfect answer to it, but you can get anecdotal examples. So you can look at red teaming or sort of pen tests, external or internal, that try to find flaws, and you want to say, well, how deep did they get, and did they penetrate? You can look at bug bounty programs. So to the extent that your bug bounty program has remained consistent, you should be. The best bug bounty programs, actually, you're able to spend more and more per bounty because you're getting fewer of them. So are you actually getting fewer of them that are real in your system? So that's a good kind of continuous monitoring type element. So those are kind of the three that I see. I think all three are good. And I guess maybe, one more thing to add there is there's measuring and there's visibility, right? So we just said security is invisible, and you want to measure it. But before measuring comes the point of just surfacing. Developers generally would rather write secure code than write insecure code. Most of them, vast majority of them. But oftentimes they just don't know. They don't know this library is vulnerable. They don't know this code they have has a security mistake. And so step one is surface it, make them aware of it. And it's not, yes, you need to train people, but these things are hard. These things are kind of hidden. So So I think it's visibility first, and then kind of measure it. And then the measurement needs to not just be about visibility, but also about actionability. Are you actually fixing the things?
Absolutely. And on the subject of like measuring things, KPIs. Do you think that we can create KPIs and I guess incentives that drive people in the wrong direction or lead people to game the system? And I guess how do we de-risk that? How do we create things that ultimately lead us to the right outcomes?
Yeah, I think so. KPIs are hard, kind of for the same reason around sort of the measurements, but massively crucial. The primary advice I'd give in KPIs is that you want to separate the KPIs of the activity from the debt. Almost invariably, like when you haven't used a certain sort of you haven't tested for a certain security risk, and you now run some tool. It's going to be an unpleasant moment. You're going to uncover a bunch of debt. There's going to be, a whole bunch of these types of vulnerabilities and concerns that you have there, just like, frankly, any kind of logging software or any times you sort of add visibility on something. And then people put KPIs, and sometimes they over-rotate on not having vulnerabilities. My advice would be, I think the ones that succeed the most are the ones that address 2 or 3 different paths, and I keep breaking things up here into pieces. But one is stop the bleeding. So you start by having KPIs that relate to the addition of new problems. So can you put controls in place so that you wouldn't add new vulnerabilities or new vulnerable libraries, or when new disclosures come along, are you handling those? Same for threat modeling and things like that. Like, are you, whatever security measurement you're doing, whatever sort of visibility you're introducing, how do you not get worse? Because as long as you haven't done it, you've got a leaky bucket, and it's not gonna help you. So that's one. The second is you want to measure response and kind of fix SLAs. So I told you about a new critical vulnerability. You should be fixing it within whatever, a day, 7 days, 30 days, whatever you've sort of defined in your system. Are we adhering to that? So that's about practices. That's really around saying, are we establishing good security practices? And then only the third is really the debt. Fundamentally, the debt is indeed there, and it is indeed making you insecure. And so you want to incrementally kind of eat at it. So I think those are probably the ways to think about it. Also, probably the staggering, if you're not measuring KPIs for security at all, that's probably the sequence that I would advise doing. But probably the biggest, one of the biggest like failings maybe of the security industry is that it's all stick and no carrot. Like, there's no, you really get scared into submission in most of sort of aspects of security about this is this horrible vulnerability. How can you sleep at night without fixing these issues? But there's way too little recognition of success. So I think what you need to just make sure is that whether it's KPIs or it's side recognition, is to make sure that you also celebrate that people that are doing it correctly, right? If you think about DevOps and you think about what made it successful, it's around sharing, it's around collaboration, it's around blameless postmortems, it's around really kind of being in it together. And you can do all sorts of fun things. You can create leaderboards in which you celebrate someone that's the top, not shame boards, leaderboards, who did the best in terms of, say, whatever, addressing vulnerabilities or preventing them. You can do security swag, whatever. You can kind of have T-shirts that talk, say, security hero, or I know Duo did this Slack bot that publicly recognizes the first person to patch their system when they sort of released like a new version of updates, for their internal systems. It just, some form of races or games or celebrations of people that did it right. Because otherwise, it would always be a thing that people dread. Security would always be something people wouldn't want to embrace, because at best, it doesn't reprimand them. And that's just not the way you kind of change human behavior.
And you touched on the individual there, and like thinking about, I know our industry and the tech industry is almost obsessed with synergies and finding better and bigger synergies that yield more. And I guess, is there a risk that we overload our engineers with asking too much of them and just creating too much for them to master, and they become jack of all trades and master of nothing?
Yeah, I mean, I think it's funny, you talk about engineers, software engineers, and it's the whole kind of, it was the best of times, it was the worst of times type reality, right? On one hand, you see the, pandemic memes talking about how, you're a software engineer and therefore, sorely, you're so sad that you had to work hard from home and all that. On the other hand, you were getting paid pretty darn well, for, as compared to many others in the pandemic. And so, I think when it comes to engineering, we want to drive to these independent teams, and we want to help them, be independent and run fast. And as a result of that, they're responsible for everything. Of course, the functionality of the product and operating it and keeping it secure and making it accessible and keeping private data and. So absolutely, we are kind of overloading our engineers. I think the answer to this is really platforms and tooling. Like fundamentally, what we need to do is we need to figure out how do we make it reasonable, if not to say easy, for them to embrace these responsibilities. So, for example, if your solution predicates, right, if your methodology or engineering methodology predicates on your engineers being experts in every one of the fields that I specified, I don't think the future kind of is bright for you. On the other hand, if you're assuming there is some base level of knowledge that the engineers need to have in these spaces, but they need to be experts in their app, not experts in every one of these fields, but that they are equipped to be able to find these different problems, that's the way that you succeed. And being equipped is a variety of things. Sometimes it is about skills and how to sort of use them, but oftentimes it's just about tools that offload it from you. Sometimes it's platforms. If you think about serverless, for instance, I have all sorts of critique about serverless, but for example, it's a choice, it's a means in which you take away the concern of patching your servers. But if you're using containers, and there are many reasons to use it, you have to acknowledge that your developers are now making operating system related decisions, and that they need to patch those servers. It needs to be a part of their activity. And now the question becomes, how do you make it easy for them to know when to patch it? How do you make it easy for them to patch it? So yeah, I mean, are we taxing them? For sure. And I think really our job, both as an industry and as engineering leaders, is to think about how do we make it easy. The one thing I would say is like we don't really have a better other option, right? Like, what's the alternative? Is like to move slowly, and you'll go bankrupt. You wouldn't really kind of be competitive on it, or not be secure. That's also not like an awesome declaration of intent. And so fundamentally, we want to do all these things. Yes, we need to prioritize. But I think that's the reality. The commercial incentive, the kind of capitalist incentive to be agile and fast is alive and well. Those are the businesses that thrive. Those are the businesses that succeed. They need the independent teams. The more independent your teams are, the more they scale, the more the organization can scale, because you can battle on many fronts. And so that's also a demonstration. You see all the sort of the tech giants. That's really how they thrive. And so fundamentally, I think the only and the best and a pretty good solution for you to embrace is one of platforms, and platforms and tooling to enable, to empower, to equip developers to be able to deal with that sort of large amount of responsibility and breadth of it.
Now, I reckon we've got time for an ultra quick one before we wrap this session up. So we touched on the individual. How about our leaders? How important is it for our leaders to understand their exposure and their security risks? And is it just technology leaders, or is it leaders in the business as well? You've got about 45 seconds.
So I think engineering leaders should always know what are the biggest risks in their systems and what is it that they are doing about them. And they should make room, both kind of cover their people and sort of fight for more of that room, to allow their developers to do security well. The solution is not to expect developers to not introduce security into their planned work, but still be secure anyway. So as a leader, I think you want to do that. And again, you want to just vet that the right knowledge and tools are at your disposal to do so successfully.
Great, quick answer. So, Guy, thank you so much for talking to us today. And for the audience, you can connect with Guy and myself after the event using the links in the chat, which I hope are there because I didn't put them there. It's been really awesome. And I think if you go onto social media, you can probably find Guy and myself just by Googling my names.
Just Guy Podjarny all around. Thanks, Aubrey.
Awesome.
Thanks, everyone.
Thank you for today. Cheers.